This is the third video for division. In the last two videos we did TEKS 4.4e and 4.4f. This is where we talked about the different strategies and algorithms students could use to divide up to a 4-digit dividend by a 1-digit divisor. Now we're going to take what we've learned about division and we're now going to apply it and put it into a problem-solving situation, a real-world situation, so what we call in context. So you have two TEKS that we're looking at. 4.4h, we have to solve 1- and 2-step problems with division, including interpreting remainders. And 4.5a is about representing multi-step problems, using that strip diagram or an equation with a letter standing for the unknown quantity. So I want to kind of just start by looking at a page from the instructional talk, and it's about interpreting remainders. So when we talk to kids about interpreting remainders in problem solving, when we've been doing them, it's really important to give them situations, and I'd have them even act out situations. So give them a situation and say, well, how would we do this? It could be a bus situation where you're all going on a field trip, and actually a car situation, and so we have these cars, they can hold to 4 people. How many of us can they take? How many vans would they need? And so forth. So we're going to talk to kids about the different things that we can do with the remainder in problem solving, and it's really about them understanding the situation. So once again, we can drop it. So the remainder may need to be discarded. It may not mean anything. Okay, I may just need the whole number in the quotient. So for instance, if I have 30 ounces of milk, how many 8-ounce glasses can I fill? Well, I can fill 3 glasses, but I'm going to have a remainder, but that wasn't the question. I just wanted to know how many glasses I would need to fill. Okay, so I may need to drop the remainder. I may need to add the remainder to the quotient. So the remainder can force the quotient up to the next whole number. Okay, so for instance, a van holds 6 people. How many trips to get all 25 people to the airport? Okay, so I have to make 5 trips. I'll have 4 full van loads, but then I still have 1 person I need to take. Okay, so I can't leave that person back at the hotel. I need to get them to the airport. So that's part of the answer. And sometimes the remainder is the answer. So I have 25 candy bars. There's 8 boys. How many candy bars will be left? Over, left, not shared, whatever it wants to say, but it actually is the answer itself. Okay. Now, share it is something you're not going to teach the students. I put this is for teacher knowledge only, and it's going to happen in 5th grade. So we want to make sure that drop it, add to the quotient, and the remainder is the answer are really heavily taught and understood in 4th, because in 5th they're actually going to have the remainder become a fraction. And it's going to be that whole share it, interpreting remainders. Remember, when problem solving, of course, QtPack is key. We have to give students the directions to solve problems, and that is QtPack. So remember, do not teach keywords. I see a lot of each being taught in multiplication and division. Each is a keyword. I can use each in a problem where each is in an addition subtraction problem. So make sure that you're not teaching each. Teach them the context of the problem. Sometimes with problem solving, I've seen the get chart. I like the get chart because it's not about the keyword each. It's about looking at, in the problem situation, do I have a number of groups? Yes. So it may be there are 3 groups. Okay. Do I know how many are in each group? There are 12 in each group, and I'm looking for a total. This means I'm going to multiply, right? If I know there are 3 groups, but I don't know how many are in each group, and I know there's a total of 36 of whatever it is, I know I'm going to divide. if I know that there's a total of 36 items and there are 12 in each group, and I'm trying to figure out how many groups, it's also division. So the get chart is, and I've seen it kind of done like this, the get chart is helpful for students if they're really having a hard time comprehending whether they need to multiply or divide in problems. They can use this model, okay? So that's been quite helpful for people. But please make sure not to have them do this wonderful interactive notebook thing where it talks about each, and when I see the word each, I have to divide or multiply. That's making each a keyword and takes students' comprehension of the problem out. They just start looking for a keyword, okay? Remember that in QtPack we're pulling out all of the information and putting it inside a graphic organizer. There should be no circling or underlining, only allowed. If you do that along with pulling out problem information, that is fine. We've talked about representing with a strip diagram in multiplication. The same thing's true with division. So we're representing with the strip diagram. So I have a total of 36. I know I'm putting it into 3 equal groups, as equal as we can get them, right? And so how many are going to be in each group? Okay, so the key here is making sure that their models, their strip diagrams are as, the parts are as equal as possible. We want to stress that. All right, make sure that you just represent all problems for the rest of the year with a strip diagram or equation. They've learned now all 4 operations and have problem solved with 4 operations. So from the end of December for the rest of the year, your goal is to work towards mastery of problem solving with students with addition, subtraction, multiplication, and division. All right, I'll see you next time.